The purpose of this video is to look at an interesting problem which is related to congestion. Now, it's a general problem, but we are going to look into a specific use case which is related to buses. So, what do we mean by related to congestion in buses? It means in a normal road, you might have uh, come across a circumstance that many of the buses are stuck in a traffic light or probably some places which they shouldn't be normal. So the reason is traffic, probably some accident, probably anything else. So we are going to look into how we can detect such kind of patterns. So let me just give you an example. So as you can see in these images, you can see a lot of vehicles are kind of staggered across in a particular region, and similarly in the other photographs. So it's a kind of a congestion kind of problem. It means a large number of vehicles are closely grouped together. So now this problem of what I'm showing you right now, it's a computer vision, but we are not going to solve it by computer vision. That's a different kind of approach. But we are going to look at the output which has been provided in a form of text. So what I mean by that is, let's look at a specific example, the Chicago CTA API, which has been exposed by the department. So what it does is, it allows us to query the current system of the bus network, and it provides us with a lot of information in written JSON kind of format. So what do we mean by that is, they provide us information like they provide us with routes, how many routes are available, and what are the bus stops on which generally bus stops, and it provides us the individual latitude and longitude information of the individual buses. So instead of looking at from the computer vision perspective, we are going to look from the geographic perspective. So if we have latitude and longitude, we can exploit that information to derive whether there's a congestion in certain place or not, or whether normally the bus is just stopping because of the bus stop kind of a thing. So we are going to evaluate a couple of algorithms and see which one suits most in this kind of scenario, and how we can plot in an interesting way that you get a feel of the actual geographical information on how latitude and longitude can come into picture in that area in detecting these kind of problems. So this is a general purpose problem, can be extended to anything. So the takeaway from this problem would be that if we have some kind of a geographical information, for example latitude and longitude, we can detect any pattern of similar nature.